In this video, I'm going to do two questions from the chapter Circle, class 10th, as based on the property tangent from same exterior point. So let's begin with the first question. In this question, it says in the figure, a right angle triangle ABC. You can see this is a right angle triangle ABC and right angle at A. And this is circumscribing a circle of radius R. So the radius is given as R. Further, we know the length of AC and AB as 8 and 6. I should write down AB as 6 centimeter and AC as 8 centimeter, right? What we have to find out is the length of this radius. Well, this can be done by two methods. One by using tangent from same exterior point, another by using the property that is formula that is area of a triangle. Well, I'll go by the second method. First, I'm joining the radius with the point of contact. Sorry, center with the point of contact. And you know that radius is perpendicular to the center at the point of contact. And then I'll join this also A with O and O with B and O with C. I'm doing by this method as you are aware of one such question you have done in textbook that uses this property. Now, first we are going to say that this is triangle ABC, as you can see, is made up of three small triangles, and I'm coloring it so you can figure out. So as you can see from the figure, this is triangle BOC. And lastly, we have one more triangle, say this one. So we have these three triangles. Now what I can see that from the figure, we can say that this triangle, that is area of triangle ABC, should be equal to the sum of area of three triangles, right? These are area triangle AOB plus area triangle BOC plus area triangle, that is AOC. Now we know that area of a triangle is half base into height. So this is half into base. As you can see from the figure, what is base? Base is this 6 centimeter and altitude is 8 centimeter. So I can replace base, which is 6, into altitude, which is 8. And on the other side, area of triangle AOB is again half base into height, that is AOB, as you can figure out from here. I'm talking about this triangle. In this triangle, base is 6 and altitude is what? The radius. This is the radius, that is R. This is also the radius. So it's half into base, which is 6, into altitude, that is R. Then we have the next triangle BOC. Here too we'll apply half base into height. Well, BOC, you can see from here, BOC is half base into height. Well, base is, okay, base we haven't calculated. That's what we should have done earlier. So you can see that using right angle triangle Pythagoras property, I can say BC square will be what? It should be 8 square plus 6 square using Pythagoras theorem. So 8 square is 64 and this is 36. So it comes out to be 100, right? 100. So we can say that the length of BC will be under root 100, which is 10. So this length is 10, BC. BC is 10 here. So now for finding the area of this triangle, that is here BOC, that's half base into height. So we can say the base is 10 and the altitude remains R here, that is the radius. Plus half of half area triangle AOC. Well, AOC is this triangle. Here you can see the base and the altitude. So you can see that base is what? Base is 8 and the altitude is R. So that's half into base is 8 and the altitude is r. You can see that you may take half as common from both sides and cut it. So now 8 into 6 is how much? 48. And this time, this side it is 6r plus 10r plus 8r. So this is 48 and this is how much? 24r. That implies r is equal to 48 divided by 24. That is 2, right? So r comes out to be 2 centimeter. So this is what we are asked to calculate the radius, and we got radius here as 2 centimeter. That's how we complete it. In this question from the chapter Circle class 10th, that uses the property of tangent from same exterior point. So let's say if what the question says, it says in the given figure, a circle is inscribed in a quadrilateral ABCD touching these sides at point P, Q, R, and S. Right. Further, it says that if the radius of this circle, like this being the radius, or maybe this, you can take the radius is given as how much? 10 centimeters. So I'll write it 10 here. So this is, you can take 10 centimeter. This is also 10 centimeter. Further, we are given the length of BC as 38. This is 38 centimeter. This BC being given as 38 centimeter. And PB, this is 27 centimeter. What we have to calculate, okay, one more information is given that AD is perpendicular to CD. That means this angle is given as 90 degree. We'll take this angle as 90 degree. Now what we have to calculate is the length of CD. That is, yeah, you have to get this length, that this total length C to D is what we have to get. Now, as I said, this is based on tangent from same exterior point. So can I say that the length PB is equal to BQ from tangent from same exterior point? So it should be 27. I repeat, what you can see here that the length PB and QB, they are tangents drawn from the same exterior point. So I can see their lengths will be equal, and I can write BQ as 27. BQ as 27 centimeter. Now check here, we know the length of this whole length we know, right? From here to here, it is how much? 38. This is 38. And how much is this? This you can see, I should show you once again. We know this whole length as, we know this whole length as 38, and we know this part as 27. So by subtraction, we can get the length of CQ. So I can say that CQ should be equal to BC minus BQ. And BC is 38 minus 27 should give you 11. So we got this length as 11. Now check again from tangent from same exterior point, I can say RC will also be 11. That means here RC will be equal to CQ, giving the reason tangent from same exterior point is equal to 11. Now, what can you say about this this figure? As you can see, we are talking about this figure. Check here. What we know that radius is perpendicular to the tangent at the point of contact. So this is 90 degree. Well, this was angle D is already mentioned 90 degree. And from the reason that radius is perpendicular to the tangent at the point of contact, even this angle is 90 degree. So as you can see here, we have a quadrilateral in which all three angles are 90 degree, not all, three angles are 90 degree. So by angle sum property, as you know, the sum of all four angles of a quadrilateral is 360. So this should also be 90. Now check here. If all angles are 90 degree, therefore, it's a rectangle. I can say that DROS is a rectangle. And the reason is each angle angle is equal to 90 degree. So that means all sides will be equal, and by all sides, that means their opposites, not all sides, their opposite sides will be equal, sorry. So opposite sides, I can say, therefore this length OS should be equal to dr, and OS is 10, so dr will also be 10. So now you can figure out from here that dr is 10 and RC is 11. So I can say now that the length of DC, which they have asked to calculate, is 10 plus 11, and that comes out to be 21 centimeter. This is how we will do this question.